Okay, in this video I'm going to give more specific directions about electron configurations. So the first thing you need to do is color code a periodic table if you haven't already. So we talked about orbitals in the video. There are 4 different orbitals, S, P, D, and F, and each orbital has a shape. Well, not only do we have orbitals with shapes, but these orbitals match up with certain sections on the periodic table. So these first 2 columns are the S orbital. It also includes helium. So what this means is all of these atoms for all of these elements in the S orbital have a spherical shape, and the electrons are going to be located somewhere in that sphere. We can also look at this and determine that there are only going to be 2 valence electrons in all of these elements. So remember, valence electrons are the electrons on the outermost ring for that atom. The next orbital we call the p orbital, and that's this big block in green over here. If you count across, there are 6 boxes, so we can never have more than 6 electrons in the p orbital. I forgot to mention in the s orbital we can never have more than 2. The p can never have more than 6. In the middle we have the d block. It can never have more than 10. And there's something special about the d block. This whole block is actually off by 1 row. So if you notice, I've numbered down this side. I left off 7. If we look at SC, the very first element in the d orbital, it's actually considered on the 3rd row. So you need to renumber just this d block. So this is 3, 4, 5, 6. The p block, it stays in the same order when we talk about rows. So helium is still row 1, neon is 2, argon 3, krypton 4, xenon 5, radon 6, and UUO is on row 7. So the only section that is misnumbered is that D block. So everything from SC to ZN is on row 3, Y to CD is on 4, so on and so forth. The last section is the F orbital. I have it outlined in blue. It is the 2 rows down at the very bottom of the periodic table, and you should number these 4 and 5. Now, there are certain periodic tables that are really good for electron configurations and some of them that aren't so good. If you count across the F orbital, you should only have 14 elements. If you have more than that, it's not a good periodic table to use, and you should find a different one. I can't remember what your book has in it, but if you look across, there should be 14 boxes. So that would be an appropriate one to use. All right, so we will use the periodic table primarily. One thing that you're used to using for electron configurations is this chart. And it tells us the order that we should go in. So I don't know if you can tell, we have little arrows pointing down. So we should start at 1S and go down. And then we go to 2S. And when we get to the bottom of this arrow, we go to the back of the next one. So then we go to 2P and 3S. We get to the bottom of this arrow, we go to the back of the next arrow, 3P, 4S, and then we go to the back of the next arrow, 3D, 4P, 5S, go to the next arrow, 4D, 5P, 6X, next arrow, 4F, 5D, 6P, 7S, and then 5F, 6D, 7P. You will also need to remember that the S orbital can never have more than 2 electrons. The p orbital can never have more than 6, D can never have more than 10, and F can never have more than 14. Alright, so knowing this order, if we look on the periodic table, it goes in the same order. So we have the first row, that's 1S. And then we go to the second row, row 2, S orbital, so that's 2S. If we keep going across to element number 5, we're still on the second row, and now we're in the p orbital, so that's 2p. Go down to the next one. We're on the third row. This is 3s. And then we keep going across. Now we're in 3p. After 3p, we go to the next row and it's 4s. And then look, we have number 3, 3d. So if we look on here, after 4s is 3d. What's after 3d? Well, we keep going across. This is row 4 and it's the p orbital. And then 5s and 4d, then 4p. So the rows on the periodic table follow this chart as well. So you really don't even need this chart. That's a crutch that you don't need to lean on. It's just something that you've had in the past. You won't need it anymore. Alright, so now knowing that, we're going to look at the beginning of this sheet. So on this worksheet, it starts out not with electron configuration, but more of an orbital notation. So orbital notations is the same thing as writing an electron configuration, but you're using arrows. So they have filled in part of the chart. We need to fill in here. So what we know, this arrow represents an electron. We have one electron in the 1s orbital. So 1s, that tells me row 1 in the s orbital. So if I go to row 1, s orbital, and it only has one electron, that would have to be hydrogen. Helium has 2 electrons. If I look on the periodic table, its atomic number is 2. It's on the first row. It's in the s orbital. It's the second one. So here, I'm going to write 1s2, and I'm going to write the 2 like an exponent. All right, we don't know what the next element is, but we know it has 3 electrons. I see 2 here and 1 here. Well, it has 1 electron in the 2s orbital. So I'm going to look on my periodic table. The second row, s orbital is lithium. It's the very first one. So 2s1 would be lithium. If we were to write that out, we'd say 1s2, 2s1, and that's what they have written here. So then it jumps over to carbon. All right, so carbon is on the second row of the periodic table. It's in the p orbital. It's the second element in the p orbital. So we know that our electron configuration is going to stop at 2p2. 2 because it's in the second row, p because it's in this section of the periodic table, and the second number 2 comes, I counted over, 1, 2. So if we look on our worksheet, they filled in orbitals, so there's 2p1, 2p2. So now we need to write all of that over here. So in 1s, I have 2 arrows. So I'm going to write 1s2. In 2s, I have 2 arrows, 2s2. In 2p, I have 2 arrows. One there, one there. So that would make a total of 2p2. Right, on the next problem, we have 2, 4, 5, 6, 7 electrons. So if we look on our periodic table, element number 7 is nitrogen. So we can just put an N there. But if we look at this electron configuration, we always start with 1s. There's 2 elements in the 1s. Let me expand this out. So this would be 1s1, 1s2. And then it says 2s2, so 2s2, 2p, and we count over 1, 2, 3. So this is how they got 1s2, 2s2, 2p3. Oxygen. They've put our arrows, so we have 2 electrons in 1s, 2 in 2s, 2 in 2px, 1 in 2py, 1 in 2pz. So to total this up, we have 4 electrons total in 2p. So I'm going to write 1s2, 2s2, 2p4. And this is okay because we know here we can have up to 6 electrons in the p orbital. So having 4 is fine. All right, I'm going to leave you the last 3 to do on your own.